Alright, we're going to wrap up 1-8 combinations of functions, where we're talking about composite functions, in 2 final examples. So what we are going to do is we're going to find the domain of f of g of x when we know f of x is going to be x squared minus 9, and g of x is going to be the square root of 9 minus x squared. So we want to first find f of g of x. So let's do that. We're going to take g of x and we're going to put it in to x in f of x. So we're going to have the square root of 9 minus x squared minus 9. And the squaring and square root cancel each other out. So we're going to have 9 minus x squared minus 9. And these 9's cancel each other out. So we're going to end up with just a negative x squared. Now the domain of f of g of x is restricted by the domain of g of x. If we actually were to graph x, or the square root of 9 minus x squared minus 9, it would roughly look like this. Oh, whoops, nope, I graphed that wrong. It would roughly look like this, where it stops at this value. So right here we've got the origin. This value it stops at on the x is 3 and negative 3, and on the y we have negative 9. So that means the domain of our composite function is restricted from negative 3 to positive 3. If you were doing this on your own, what I would do is I would plug our composite function, before we do any simplifying, into a calculator and see what restrictions do we have. Alright, let's look at one final example where we are going to decompose a function. Alright, we are going to write the function h of x as a composition of 2 functions. And h of x is going to equal 1 over the quantity x minus 2 squared. Now, when we're asked to decompose this, we can play around with it however we want. What I'm going to do is I'm going to say we're going to let g of x, we're going to define a new function and we're calling it g. It's going to equal the x minus 2 part. And we're going to let f of x equal 1 over x squared, which, if you recall back to Algebra 1, or just recall your properties of exponents, can also be x to the negative 2. we're going to use this idea just to go backwards from h of x to show we have a composite function. So we're going to rewrite h of x. We'll do that over here. We're going to rewrite it as x minus 2 to the negative 2. And in our little deals where we said let f and g equal certain things, we know f of x is x to the negative 2. So we have f of x minus 2. We also said that g of x was x minus 2. So we can say we have f of g of x. So we've decomposed h of x, which was 1 over x minus 2 quantity squared, into two functions. One function being x minus 2 and the other being 1 over x squared. And that is it for lesson 1.8 on combinations of functions, looking at composite functions.